Yeah, hello. So in this video, we'll see MLFlow, which I run in my local. So basically, MLFlow is used for experiments tracking, registry, and what serving. Those things we can do, and also we can while registering the model, we can put it in production. The same model we can use it on the deployment also. It is quite useful to deploy or create a machine learning pipeline end to end in a very quick time. So we will go through a few codes here. Like for example, I have created a pipeline here. So if you so if I run this particular main file, it will trigger all my. So I have imported all the files here. So it will respectively call the methods defined in that particular file, and it will uh, take the return and it will pass it to the next method, and it will like basically run the pipeline. So what I'll explain the. So if you see here, so we are this is for like argument parser is like when you run this particular file main.py, it's like customizable. You can give these arguments if you want, or it will take this default value. So like so we can have this five parameters, and we are calling this particular method which is defined here, right? So in this method what we are doing, so first we are calling this load input function method, sorry, which is we imported here. So if we go to particular file, we can see the particular load input method. So why this particular line, what we are doing here is like we are setting up the DB basically to for registering and all. We need the database. So if you don't set this, we'll be not able to register the model. So that's the reason we are doing setting up. So if you also see, there is something called as ML runs.db created, and while getting the MLflow UI also, you have to give in this particular format, where like MLflow UI backend store, you have to mention this thing also, DB also. But optionally, you can also mention the port here. Like you can mention if you want to run in a specific port, you can also mention that. So for example, so if you can specify your own port also in this way. So I'm running so now I'm running in the default 5000 port. So I can run this particular file even with a single file alone, so which create set the experiment, and then basically for every experiment there will be one respective ID. So if you see here in the ML runs folder, this is the experiment ID 0, and this is the second ID 1. So this has the experiment name also tagged to each other. In this particular experiment, these are the different runs. So each run has its own ID also. So if you go to inside run, there will be artifacts, matrices, metrics, parameters stored. Like while running the model, you would be like after training, you would be like saving a trained model in the artifacts. That's one thing. Or if you want to tag, matrices, all these things you can do basically. So that's what we can do. So in this particular file, so we are starting the run, and we are, so what we need to basically understand is like we are taking this file name. So file name is nothing but a CSV file. We must be like giving us an attribute here. So what we are doing, we are first logging it that input file without pre-processing. We are logging it as an artifacts so that we can refer it later. So take the input file from this file path and put it in this artifact directory, which will be inside your run ID, and inside artifacts folder, it will create a folder called data, and it will insert your this thing. your input data. Okay. So I'm just running that particular file alone, s1.data.py. So we'll see. So I'm running MLFlow pipeline inside this directory. Okay. So it must be creating inside the same experiment. So if I see here, see experiment ID is 1. So if I go to this experiment ID, the new run which is set today is this one. This is the ID created. So you can see data. You can see that input file which we pass. So it will take that particular file, input file, and place it here. Why? Because in the next, if you run some script, you have to take your data, all the pre-processing from this place only. And finally, so in the same way how we have this data in this particular artifacts folder, we also have our model files also in this artifacts folder. Then we can take those models and register it. So while registering, it understand, okay, I have to go to this particular experiment, and inside this experiment I have to go to this run ID, and inside this folder I have this model file. So it will have create the model URI for you, which you can like after registering, it will create the URI which you can use it for deployment, batch transform or real-time processing. Like basically batch transform, you will load the model from this place. For real-time inferencing, it will create an endpoint where it will trigger this, takes the model from this particular place. So this is what we are doing it here. And then, so the same code which will be available from this place. Okay. And then yeah, so this is the first play, and then pre-processing, then this again like very similar thing. The only concept which we get to know is like from here after we will like get the data from that from this particular place only, like from this place only we will take the data. So you can see from this experiment ID, from this particular artifact location of this particular run ID, take the data, do all the pre-processing. In a same way, log the artifacts. Like we have something from the temporary directory, all these files, take it and save it in that particular data folder, same only. So if I run this, so you can see we are just again taking a few files from this temporary directory, and we are again placing in this particular folder only, this folder only. So that's what we are doing. So we're just logging the artifacts, select method from the MLFlow itself. So once you have done, again this is also like syntax for xtrain, xtest. Just using the train test split class, we are just doing the split, and then finally again saving it in the same place. So this code also you can find it here. Okay. Yeah. So this thing also completed. So you can see all the files here. And the third thing would be training. So this is also very common. Take the read the files from this particular artifacts data folder and do the training. So what we are doing, so we'll take all the folder to like start the run. We know the run ID, we know the experiment ID. So in that we are in that particular experiment and we know the run ID, so we can create the runs and we can do like everything. So basically then we can like see we are logging the parameters. So if you go to the particular from the UI, you go to the particular run ID, and if you click the run ID, you can see the parameters and matrices logged for this particular run ID. so which you can do. Training also completed, so I'll just go to that UI, and if you see here, so I am in this particular experiment, and inside the experiment ID is 1. So these are the different runs I have under this particular experiment, and this is the run which I recently completed. So you can see the parameters, matrices, everything, and the artifacts also, which what you have in this particular local directory. The same thing also available here, and you can also see what are the models which you have used. Everything you can see. But one quick thing is, like, I guess in the Databricks, I believe you can see the notebook also, which created this particular, this result. That also you can see. This is local open source which I am using, so maybe that is not available. So yeah, see the source which has been used for to run this particular thing. Okay, but I am not able to see that file. But yeah. So again, fourth thing would be registering, but what I don't think it will work, but let me try. But yeah, same code will be available from this place, training code, and then this is what registering code. That's what I'm running. Yeah, so this also completed. So what I'm doing here is, like, if you see same thing, so I will just so I'm trying to register a model. So what I will do, I'll go to the particular run, and I'll see which model is in production, and whatever model I'm currently running, if it crosses the evaluation, basically the accuracy or reference score or whatever, if it crosses that, I would like to convert my present model into transition stage, maybe production. But before that, first let me explain you what see. I have some model which I already trained, and also I know the place where the model is available. So from this, so this is the model which is trained just now. So I know this place. So I'll go this particular run, inside this particular churn model folder. I have that model. First register it. So registration is completed. So if you go here in this particular place, if I just refresh, I can see the model has been registered 2030 8:30 now only. So the model has been registered and the registration is completed. But if you see, there are different versions in it, and so what they are telling is, like, see, before there must be some model which was already in production. So when you are registering the model, when the initial time, what you have to do is, right, you can tag whether it is in staging or production. Let's say for the first time, if I am running the model, I have tagged it to production. So next, whenever I run, I compare the accuracies of already tagged model and my current model. If my current model is performing better, I will convert my current model into production state. That's what has happened. So active model is 81. Whatever already has is 80. So I am converting my active model into production. That's what happened here. See, before that some model was in production. So I converted my current model into production as of now. I don't know why there are two production models, but that's what happening here. So I will just compare the active model accuracy with the production model accuracy, and if my active model performs better, I am obviously transferred it into production. So same code will be available from the same place, and finally it would be yeah. So for prediction, so before that I would like to explain few things. So, like, let's say you run this python.py. Yeah. So training, load input, pre-processing, training, registration, registry, everything is completed. Now deployment, coming to deployment part, this is for batch prediction. So what you can see, I'm just created one HTML kind of thing where you can It gives first let me check if the code is available. Yeah, this code is for this one, after model saying real-time prediction, and this is the main file, and this is the app file which I'm currently running. Yeah, and this is the index.html file. So this what this app will do is like, basically when you run this app.file, it will load your model from the particular production, whatever the model is in between, it will load your model. And I guess I cannot go into that UI because this is also running in port 500, and my current this is also running in port 500, so I must have given some other port here. If so, I could have run this model. Let me try in income, but I don't think I can go. No, no, see, it will go to the same MLFlow. So yeah, I okay, so my MLFlow is running in port 5555, and this app.py is running in port 5000. So by default, it calls this method, which is just returns welcome. So let's say I go to okay, let's say UI. See, it calls this particular index.html file, which is again, it should be here. Sorry. So this file also, I have it here, this file. So basically it will give you a basic HTML file which will give you this screen. So once you enter all the details, I have in this file, right? So once you enter all the details, it will call this this method, predict method, and it will basically do the prediction. Basically it will take all data which you are entering from this place, and from this it will take the data and does the prediction for you. I will just give a random score. See, it's a very not a good model. So yeah, that's what. So this also. So this is the batch transform method. Real-time inferencing we will discuss in the another video, because we have to serve this model so that we can inference using this API. That we will see it in the next video.